Hey, this is Mr. Boone. This is Geometry 3-3. Proving lines parallel. Please write down your objectives to determine whether two lines are parallel. Okay? So once you get those down, you have to think, all right, we've been learning about angle pair relationships. Okay? On Friday, or our first day, I should say, in section 3-1, we learned about the fact that if two lines are crossed by a transversal, we have angle pair relationship. Alternate interior, alternate exterior, corresponding same. Those four things go on. Okay? On 3-2, we learned about the fact that when a transversal crosses two lines that are parallel, not only do we have those relations, but corresponding angles, alternate interior angles, same side, corresponding alternate interior, alternate exterior, are all congruent angles. Okay? And then we're looking at the idea of same side interior being supplementary. Does that make sense? Okay? That there are properties that happen when the lines are parallel. What's different about today? Today we're going to do the converse of those. And remember when we did converses, you had P implies Q on our original. We had P implies Q. And then our converse is Q implies P. So we're doing the converse of what we've learned already yesterday. So what's that? Yesterday you learned when you have parallel lines crossed by a transversal, then the alternate interior, alternate exterior, corresponding angles are congruent. Yesterday you learned that if you have parallel lines cut by a transversal, that the same side interior angles are supplementary. The difference today is we're doing the converse. So if I have two lines cut by a transversal, notice they're no longer parallel, but I have two lines cut by a transversal, such that alternate interior, alternate exterior, or corresponding angles are congruent, then the lines are parallel. Okay? If I have two lines cut by a transversal such that same side interiors are supplementary, then the lines are parallel. Okay? So these are now properties to prove that the lines are parallel, instead of properties that extend from the fact that they're parallel lines. So that's how we're going to be using these today. So to work with this, to help shortcut stuff, to show angles are congruent, we've been using corresponding angle postulate, alternate interior angles theorem, and alternate exterior angles theorem. Okay? So that's the first stuff that goes in that first box. So that's the first stuff. Now, to show angles are supplementary, we've used same side interior angles theorem. Well, yeah, that's what we did yesterday. Okay, in section 3-2. Today, the difference, and make sure that you're clear about writing things down, because these are your notes. Today, the difference, to show that lines are parallel, because you can guess, well, how do you know the lines are parallel? How do you prove the lines are parallel? For what value will make that the lines are parallel? To do this, we're going to use the converse of those very same theorems. Now, please notice, I'm talking about 8 different theorems. 8 different ones. Okay? So since I'm talking about 8 different theorems, you've got to know that they're different, and if you mix them up, if you're like, say, if you're trying to prove lines parallel and you're going to use corresponding angles and use cap, as opposed to the converse of corresponding angles postulate, which is CCAP, those are different answers. So you have to be ready to realize that. Okay? So know that and be ready for it. Proving lines are parallel, you will use a converse version of the theorem. Okay? I'm just going to delay a little bit and wait for folks to get this written down. So make sure you get these things down and don't rush. Okay? Folks watching this at home, make sure you get this down too. And make sure, if you're going to use the shortcuts, make sure you know what those mean. Okay? If you're going to go CCAP, great. What's it mean? I expect you to know. I expect you to know what CCAP means in 5 months, 4 months. Okay? For semester 1 final and for the end of the year final if we use it. You need to know what those are, so you'll have those notes. Okay, so we good? Okay, anybody need more time? All right, slide out here. So our next thing on this, on that front page, is we had to use parallel lines to find congruent and supplementary relationships for special angles. We had to use parallel lines to find congruent and supplementary relationships for special angles. Just red run, sorry. Now we need to turn it around. To reverse the statement, we will use the converse. Okay, we're going to use the converse today. You can use certain angle pairs to decide whether two lines are parallel. So you're going to be proving lines are parallel today. Okay? So you're given the properties. You've got to name the angles, know the property with the name of those angles, and see if that's provided. Then, if that's true, then you can prove the lines are parallel. So let's see how this will work today. So we're looking at the converse of corresponding angles postulate. Okay? If two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. So this is really then the lines are parallel today. So let's talk about this. 2 and 6 are corresponding angles. These two angles are corresponding. They're on the same side as the transversal. Okay? They're in the relative same position, the top right corner of the intersection. Then, if this is true, then the lines are parallel. L and M are parallel. Okay? Now, how does that work? You identify your angles that you're working with. Here, I'm looking at 1, and I'm looking at 2. Okay? So I got 2 angles I've identified. What lines are affected by angle 1 and 2 being fixed values? And they're the same values. Okay? What lines are affected? Think about that for a second. Anybody got an idea right here? Why? What lines are affected by those being the same value? Mr. Okay, A and B are affected. What other lines affected that A and B are in there? Yeah. M is affected. Those 3 are locked in. Okay? Matter of fact, I got some people staring at this one. Well, what about L? Well, what about L? I mean, L could be a top. There's nothing telling us that L is doing anything but spinning like this. Okay? So that's kind of out of our way. We're going to kind of try to ignore L if we can. I'm just going to get rid of that and cut that out. But these are the 2 lines that are going to be parallel, A and B. Okay? What type of angles are 1 and 2? What's their name? Alternate interior, alternate exterior, corresponding, same side. What are they? Any takers? I got a number in my head. Wait. Got a number in my head. Got a number in my head. It's not there yet. Think all. You got to think about that. So I got 2 people that know this. Come on. What's the name of angle 1 and angle 2? Alternate interior, alternate exterior, corresponding, same side. Which one of the 4? I've got 2, you got 3, got 4. Got 4, my fault. 4. What? They're corresponding angles. Fantastic. Does that make sense? So we're looking at corresponding angles. So you're ready for how I could justify this. We have something called the converse of corresponding angles. We just learned the theorem, the postulate. And what that means is, when I know angle 1 and angle 2 are congruent, then the lines that they're freezing around them are going to be parallel as well. So A is parallel to B by the converse of corresponding angles postulate, CCAP. Okay? A and B are parallel by the converse of corresponding angles postulate, CCAP. Okay? So we got CCAP. Converse of corresponding angle. I hope you start noticing that the names that we've been working on since day 1 of this chapter are going to help us launch into what the name of the angles are, what the properties the angles have, and why that's the converse theorem. And if I'm proving lines parallel, I use the converse. Okay, if I already knew they were parallel, I just use it. Okay? Now, after you write that down, which lines you know are parallel. Go to the next one. What do you know about the one below? Okay, what do you know about the one below? And that's this one right here. What do you know about this? So now I'm going to erase these things, clean up my stuff, and I'm going to talk about angle 6 and angle 7. Angle 6 and angle 7. Having those be congruent, what lines do they freeze? What lines do they make rigid in this thing? Yeah. All of them? Careful. There's 4 lines. Does it make all 4 rigid? B, L, and M. Perfect. So we got B, L, and M. Okay. What type of angle? Can you name the angle pair relationship? Alternate interior, alternate exterior, corresponding, or same side? Okay. Now, same side, be careful. 1 and 5 is an example of same side. Are 6 and 7 same side angles? They're corresponding angles. Now, are you okay with that, with the difference? Okay. So 6 and 7 are corresponding. They correspond to the bottom left of those 2 intersections. So I'm looking at corresponding angles, and instead of writing it out like I did the last time, I'm going to shorten it a little bit for you. I know that L and M, that's my fancy L. You like my fancy L? L and M are parallel because of converse of corresponding angles postulate. And you notice I asked what the angles were, and you said they were corresponding. So therefore, by the converse of that, we can prove the lines are parallel. So helping us name the angles we're working with will help us with which one of the 4 theorems we're going to learn in postulates. Okay. Now, the next ones. I'm pretty sure you probably were clued in that this was what we were going to be doing today. We have the converse of alternate interior angles theorem. Remember, that's converse. Converse of the alternate interior angles theorem. Okay. We have the converse of the same side interior angles theorem. Okay, so we have those shortcuts there. I want to make sure you see them. All right. Now remember, I'm not changing what they are. I'm just saying when you can recognize that the alternate interior angles are the same, then you can say lines are parallel. Okay, if the lines aren't already parallel, that's a property enough for you to make that assumption. Now, in theorem 3.5, if you can talk about the converse of same side interior angles theorem, okay, the converse of the same side interior angles theorem is talking about if these are supplementary, if that property exists, then the lines are parallel. Okay, so that's how this will work, and that's why I keep emphasizing the importance of being able to name the angle pair relationship. Okay. Now our last one, converse, the converse of alternate exterior angles theorem. Okay. Same idea. Alternate interior exterior angles theorem are congruent. Okay. Then the lines that freeze is parallel, so L and M would be parallel. So once I name them, I'm good. That's why having those names running through me is really important. Okay, you doing all right? Oops, somebody is showing his hat here. I want to make sure that might as well. I got to clean this up, so let's go back and let's talk about the bottom. Okay. Up next, a new kind of proof, a flow proof. Flow. You guys kind of saw it, but we're going to talk about how I know it. Okay? With a flow proof, arrows show the logical connection between the statements. Reasons are written below the statements. Okay? So we're just going to run through and see what's going on. And we're going to do it in a little bit more of a logic format, kind of like a mind map, but it's a mind map with a purpose. Okay? So when I'm looking at this, I'm going to take my given in pieces to help me combine to make my proof. Okay, and I'm going to show you it in a flowchart format. But what I always got to look at is I got 4 and 6, and I know 4 and 6 have alternate interiors. And I'm going to be real honest. If I wasn't proving alternate interior angle theorem, I would be done in 2 steps. Hey, given angle 4 is congruent to angle 6. My next step, hey, L is parallel to M because of the converse of alternate interior angles theorem. Well, unfortunately, I'm proving that, so alternate interior angles theorem is off. I can't use it, okay? So I've got to find another way. And this is my other way that I'm thinking. You see that 4 and 2 are congruent because of vertical? You okay with that? Now, if I can talk about 4 and 2 being congruent, I'm already told that, and I already know that 2 and 6 are congruent. How are 2 and 6 congruent? What angle pair relationship do they possess? 2 and 6 aren't an angle pair that we've been studying? Corresponding. Perfect. Okay? So we have corresponding angles with 2 and 6. So here's what we're going to do. I'm going to talk about 4 being congruent. And then by transitive property of congruence, I know 2 and 6 are congruent. And since 2 and 6 are congruent, I can use converse of corresponding angles postulate to prove the lines parallel. And that's how we're going to set this up. So I've got angle 4 congruent to angle 6. That's given. And I've got angle 4 congruent to angle 2. And that's vertical angle theorem. Those will combine, as I said, because 4 is congruent to 6 and 4 is congruent to 2. So angle 2 is congruent to angle 6 because of transitive property. Okay? So I got that going on. I should box that in. I'm looking at a little chart. It's kind of a mind-bending thing. Okay? But that's the direction we're going. What's the name of 2 and 6 again? Corresponding, right? Well, if I have 2 angles that are corresponding angles, can I use the converse of corresponding angles to prove the lines parallel? Heck yeah. So I know L is parallel to M because of converse of corresponding angles postulate. And I'm done with this proof. Now, what I'd like you to do, folks at home, turn me off. You guys, don't turn me off. All right? But what I want you to do is do the next one. It's a very similar proof. Do the next one. It's a very similar proof. I'm going to leave this one up so you can refer to it. Okay? Go ahead. Okay, now you're done. Let's look this over. Just like the other one, I went from angle 1 congruent to angle 7 because it's my given. Okay? I did my given. I'm there. And I talked about vertical angle theorem with 1, 3. Now, let's look at that vertical angle theorem. I did that, and I combined using transitive property. Well, I'm going to do the same thing here. I'm going to talk about 1 and 7 are congruent, 1 and 3 are congruent. Well, that means 3 and 7 are congruent by transitive property of congruence. Keep in mind, we've been using transitive property of congruence. We've used it extensively in chapter 2, but we started using it a little bit in chapter 1. Okay? Now, after I do that, I can name angles 3 and 7. I'll look at them, they're corresponding angles. And I'm proving lines are parallel, so by the converse of corresponding angles, L is parallel to M. Okay? And I'm able to finish up the proof. Are there any questions? Feeling okay with this? Okay? That's head bobbles. Let's get a slide on here. Okay? Now, we have now 4 ways to determine if 2 lines are parallel. I am giving you guys the shortcuts. You have to really know that CCAP is converse of corresponding angles postulate. CAIAT is the converse of alternate interior angles theorem. CAEAT is the converse of alternate exterior angles theorem. The reason I put those first is all 3 of those angles are congruent to each other for us to use it. Okay? And I use this last one, corresponding converse of same side interior angles theorem, CSSIAT, because they have to be supplementary when I use that one. Now, determining whether lines are parallel. Okay, this is another way of looking at stuff. We'll look at this fence. Okay, I've got these. The fence gate at the right is made up of pieces of wood ranged in various directions. Suppose angle 1 is congruent to angle 2. Are lines R and S parallel? Okay, if so, why? So let's find angle 1 and 2. Finding angle 1 and 2. What's the name of those two angles if I was going to, like, give them a name for angle pair relationships? That's true. They are alternate exterior. I was thinking about 3. But that's all right. Thank you. So we got alternate exterior. Okay, you okay with that? Do I have a converse to make things parallel by alternate exterior angles? Yeah. So here's the deal. I've written it out. Since alternate exterior angles 1 and 2 are congruent, by converse of alternate exterior angles, their R is parallel to S. And I wrote it out. I want to make sure that it's clear. Okay? So remember, name your angles. It pretty much tells you what you're doing. And I'm proving lines are parallel, so I must use a converse. Okay? Must use a converse if I'm proving lines are parallel. Now, in the next section, the next part of this problem, they're asking, is there another way to do it? Okay? Is there another way to do it? What do I know about angle 3 and angle 1? What is their relationship? They're corresponding. Okay? So they're corresponding. What's the relationship between angle 3 and 2? I know, it's on the tip of my tongue. What do you have? They're vertical angles. Okay, so we got vertical angles, and we can use this idea of transitive property of congruence to connect our vertical angles and our corresponding, just like we did in the proof, for a second way of looking at this. So if we're looking at a second way, we can talk that 2 and 3 are congruent by being vertical angles. And by transitive property of congruence, angle 3 and angle 1 are congruent. And since 3 or 1 are corresponding angles, then by the converse of corresponding angles postulate, R is parallel to S. Now I want to be clear about what I kind of did. I kind of paraphrased a paragraph proof on those two answers. Okay? And again, I want to emphasize this. I've been emphasizing it the entire time. You don't know vocabulary. You don't know postulates. You don't know theorems. You don't know vocabulary words. You don't know how to do this stuff. Okay? Vocabulary is how you get here. I've got Quizlets posted in your chapter 1, your chapter 2, and chapter 3 folders. If you don't know vocabulary, practice them. Practice them over and over and over. It's not simple, okay? But once you start doing the vocabulary, you start understanding how we set everything up. Okay? Without vocabulary, you can't really use it. Okay? It's not a rhythm. Now, with those two things said, what is the value of x for which A is parallel to B? What is the value of x for which A is parallel to B? This is a self-quiz. And here's how you do these. Before, when we did it, we knew that there were parallel lines and that they would have to be the same. I'm asking you, what value x will make A and B parallel? So just make the assumption they're parallel and give me the value that A and B are parallel. What type of angle are they? Alternate interior, alternate exterior, corresponding, or same side? Same side. What's the property that same side interior angles have? What's their property? They're unique. They're unique in the form. The two angles do what? Just throw it out there. Well, corresponding angles are equal. Alternate interior angles are equal. Alternate exterior angles are equal. Or all same side interiors. They're unique in the form. They're supplementary. Okay? So if they're supplementary, I can totally take that and make it happen that way. Okay? Supplementary angles. I know their relationship. I know the name of the angles. Okay? I know how they're related to each other, and I know that they'd be supplementary. They're same side interiors, and same side interiors are supplementary, and I go after it this way. If I didn't know that, I'm kind of dead in the water and I'm guessing. Okay? So I've got combining like terms, and then subtracting, division, and x is 30. Okay? Well, I should check. Let's see if x was 30. Well, 2 times 30 is 60 plus 9 is 69. 69 plus 111 is 100. So we got that made. Okay? Do the next one. Name them. It helps with it. I got news for you. We just did the only one that was supplementary. Go ahead, get after this one. These are corresponding angles. Corresponding angles are congruent, therefore equal. So now I just subtract, I add my 2, divide, W is 19. Okay? Now, you have to know the relationship. That's required by you. You have a quiz on this stuff on Friday. We'll review on Thursday, but the review is made difficult if you're not sure on how the names are. We've been working on those names since Friday. Now, that's it. That's what we got. That's the summary. Use the lesson objectives in your notes to reflect on what we learned today. Our objective to determine whether 2 lines are parallel, and you should be knocking out things that you know you can do. Okay? So if you got questions, make sure you ask. If you don't know vocabulary, make sure you study it. Okay? Got to make sure you know what's going on. If you're feeling lost on this, you got to come in, you got to talk. Okay? Have yourself a great day.